My name is Mark Becker. I'm Senior Software Engineer at Adobe in Basel, working usually on content and commerce. And today I'm going to talk about how you can build super fast storefront experiences with the new Edge delivery services and Adobe Commerce. To start the topic, I would briefly like to talk about the goals we would like to achieve with the integration. I'm going to introduce the new Adobe Commerce services, which are like a key part of the storefront experiences. Then jumping right into the architecture, showing you some structure and code. And to wrap up the talk, some learnings from a real-life customer project and showing you some performance patterns. All right. In general, everything we do around Edge delivery and the VIP program, our primary goal is always to create customer value. In the context of commerce, this is primarily about driving conversion, meaning like increasing the number of orders and the value of orders. For this, we identified like four key factors which contribute here. The first one is to remove as much friction from the shopping experience as possible. This includes like mainly making the site like responsive, so you can do the checkouts on mobile devices, have like seamless integrations with mobile payment providers, but also in addition to that, making sure the whole experience is like super fast, super snappy. Because like every time one of your shoppers has to wait somewhere on your site, you risk losing them and then not have the conversion. Also in general, performance is like also a key factor for the ranking of your site in search engines. So we want to make sure that we are very good here as well. The second part is about improving the experience itself by offering a more personalized shopping experience. I know that's like a lot of marketing talk now, but we already in the with AEM and CAF, we already introduced like use cases around augmenting product catalog or like pure storefront sites with content that is specifically useful for shoppers. We call this enrichment, and we made the experience that this pattern works like really well for our customers. So it was like important that we support this on Edge delivery as well. Additionally, content is not just useful for your shoppers, but it also helps them. It helps them making like a buying decision. But it serves additionally also as like an entry point for your site to have like better and more relevant placements in search engines. And then the last 2 points, I think Marcus mentioned those briefly already. So I'm primarily going to talk about document-based authoring today. So authors can achieve like a very high velocity with building or creating new content. Same applies for enrichments and for development as well, since we massively reduced like the complexity of the whole stack compared to AEM. All right, so that much to the goals. Let's have a quick look at how we can actually achieve those goals. One of the main requirements, and timing-wise, this actually worked out quite well. One of the main requirements we need is like having a super fast API that provides us access to your storefront or to our product catalog. With Adobe Commerce, they recently introduced a new set of services which offer exactly that. They now expose a multi-tenant GraphQL API with like a universal schema. You might have heard GraphQL in the context of Adobe Commerce before. This is, however, a different API, like different than the monolithic GraphQL API, both from like a schema and an architectural point of view. The setup, however, is quite straightforward. So you can use that to introduce like these new functionalities to your storefront very quickly. One thing I would like to highlight here is intelligent commerce, which is like a set of features around personalized commerce driven by Adobe Sensei. It's like a fully integrated solution starting from like instrumenting your storefront with events, like collecting everything that's happening in commerce, picking those events or collecting those events to analyze them, and then to train like recommendation models. For shoppers on the sites that use these APIs, that means they get more relevant search results and recommendations. For now, since I'm talking about edge delivery primarily, main advantage for us is here that these GraphQL APIs are like very fast and they scale very well, also with catalogs that have like millions of products. Since those services are new, of course, they will be continuously improved and extended with new features in the future. Also, as a small teaser, so the Adobe Commerce team is working on a set of components that get productized, which seamlessly integrate with the new APIs. And you can use this as a project accelerator for your storefronts, be it edge delivery or traditional commerce projects. All right, enough of the marketing talk. Let's have a look at the architecture a bit of the new services, how they work. So on the bottom left in orange, you see like your typical monolithic Adobe Commerce environment. And on the right side in red, you see the new multi-tenant services. To actually use the services, the first step you need to do is install a few modules, which include like an exporter and some admin UI. The exporter will basically take your catalog data, including how you structured it in your commerce environment, send it to the services. The services will make sure the data gets indexed properly and then also stored in like an optimized format. And from there on, it's also clear why I talk about services in plural. They're like different individual services, like catalog service, live search, product recommendations, which have access to that data. They add like additional functionality on top and expose this as an API via GraphQL. These APIs are then combined into a single endpoint in the federation gateway, and then you can use those directly from your storefront. Since this is like a very common use case in commerce, I would also like to highlight how customization works in this kind of model, because the extensibility model is very different compared to how you used to do that in the monolithic GraphQL API of Adobe Commerce. So, of course, you cannot do any customization in the red block. So any customization needs to be done on your commerce environment at the level of the exporter. So every customization needs to be done before, and then you send then the custom data to the services. Or, of course, the other alternative is that at the other end of the commerce services, you can use API mesh to then further customize the API. All right. So I mentioned that having a fast API to access your catalog is like a key requirement when you build storefronts on edge delivery services. So what happens if you do not have one available? Because that's a bit tricky. So for smaller catalogs, or like catalogs that are easy to partition, you can actually import the product data as structured data in Excel or Google Sheets directly, and then use the JSON delivery. For larger catalogs, specifically when they change frequently, you can probably leverage something like an edge worker on your CDN to have like a fast caching layer in front of your APIs. Or you can also use server-side rendering. I'll talk a bit more about server-side rendering at the end of the talk. All right, so let's jump into how to actually build stores with edge delivery. Okay, so here you can see the structure of specifically the catalog part of a storefront site built with edge delivery. In blue, you see the use case for regular content, and in regular content, what you usually have is like you have one document that drives a single page. For commerce, you might have something similar, that you have like one document that is specific to like a product or category page. But most of the time, what you want to do is like have a generic document that drives like all of your product or category pages. This means like a single document defines both like the structure and the content of all your product detail pages, for example. Also, catalog data that you're actually rendering is not stored in documents, but it's actually, again, delivered from the commerce APIs I just mentioned before. The same applies to product images as well. You saw in the previous talks how you can just drag and drop images into documents, but here for product or commerce data, the images are usually coming either directly from your commerce system or some kind of external asset management system. And for us, this means that the implementation of your blocks is like very different. So regular blocks, they primarily focus on decorating existing semantic HTML and then render like sometimes like simple data from like a query index or some kind of JSON document. For commerce blocks, this is like very different because like for like a product list page or a product detail page, those blocks have to actually execute GraphQL API calls, render the response data in HTML, and then need to deal with like a more complex state management. For example, if you want to filter products in a search. All right. Let's explain how to actually do this with the trick with the multiple pages from a single document. So in Edge Delivery, we have a feature called folder mapping. And this feature basically allows you to define a single document which will be rendered for all requests below a specific path. In the example here on the slide, /products. So if you request /products/shirt, and the document actually exists in your SharePoint or Google, Edge Delivery, of course, will render this document. But if it does not exist, for example, in the case of /products/bike, and you have folder mapping configured, it will render the fallback document you have configured. And you can use that so that blocks that render products or categories on these pages can then use like the identifier in the URL, for example, shirt or bike, and then request the data directly via the API and then render the correct product for this. Configuration for folder mapping is done in the fs-tab file, which is a file in your repository that is also used to connect your project with your SharePoint or Google Docs environment. And you can see the configuration example here on the slide. All right. In the beginning, I spoke about the importance of enhancing your store with useful content to attract shoppers. Now you might ask, this sounds a bit contradictory to the idea of having like a single document that drives the content of all your product pages. So while for, let's say, very unique or special products or for promotions, it makes sense or might make sense to create like dedicated documents for specific categories or products, this usually does not scale for your whole product catalog. Also, you might want to have use cases where you only want to specify like a smaller portion of your product pages where you want to introduce content or want to introduce content or the same set of content for multiple products or categories. And in this case, you can leverage a feature which we call enrichment. This is very easy to do. So you take some content, like a document, and you add like product or category identifiers to the metadata. The same also works with structured data in Excel or Google Sheets as well. Simply add like a column, which also contains then a list of product or category identifiers. The documents, they will be indexed and will be available as JSON, and then the structured data in Excel and Google Sheets are anyway already available in JSON. And then your blocks on catalog pages can basically load this JSON and look and do like a reverse lookup. Is there any content available for the currently displayed product? If there is any content, then they can load it, similar to the fragments which Markus explained earlier. If there's no content for this specific product or category, then the block will simply not render anything. And the typical use cases for these are usually like banners, some kind of promotions, related articles, custom attributes, and more. In practice, this looks something like this. So you have like a document at the top with some content, like just like a columns block. And in the metadata, you see the associated products with an identifier. Based on these documents, Edge Delivery will automatically create like an index, which is available as JSON, and then your enrichment blocks can basically consume this and act on the content. And to make this a bit easier for your authors, we created a product picker extension, which helps you to basically add product and category references to your content. This extension is available via the Edge Delivery browser extension called Sidekick. So you see the commerce button at the top there. but you can actually do a bit more with it. So it's not just useful for enrichment, but also if you have like commerce-specific blocks, for example, a product teaser that has like a reference to a product, or like a product carousel, which has like multiple references to products. You can also use the picker to like select the specific products and then copy and paste a block into your Word document. All right. So an important aspect for any commerce page or any commerce site is like structured data, which is read and indexed by search engines. So you can see on the screenshot below how adding this kind of structured data actually affects how search results from your store are rendered. So you can see like the pricing, stock information, and image. That's all like augmented from the structured data. There are different formats you can use. In our recent customer project, we used schema.org notation, added this via JSON LD script tag. If you want to add metadata, you can use a bulk metadata Excel file to add metadata to your pages. This specifically also works very well with the folder mapping feature. In our customer project, for a bit more convenience, what we did is we wrote like a script that automatically generates an Excel document like this for all products in the catalog. If you have an edge worker available on your CDN, you can also add structured data directly into the HTML. Same for metadata. But adding it in the browser on the client side works as well. All right. Now some of you might wonder, are fast APIs really enough to achieve like high Lighthouse scores on your stores? The answer to this is maybe. On the next slides, I'm going to show you a bit more detailed performance patterns and tools that can actually help you to further optimize the performance of your store. Again, let's have a look at the edge delivery framework, how it loads the page. So you might have seen the slide before in the talk from Markus. Just to short recap, so you have 3 phases. You have the eager phase that loads everything required for the LCP. LCP means largest contentful paint, and it's like an important performance metric. Lazy phase, which basically loads everything else, and a delayed phase, which loads everything after a few seconds, or all the things which should not impact the initial loading performance of the page. So in Blue, I added a few more details that are specific to commerce. So all catalog pages are usually relevant for the LCP. That means their corresponding blocks should always be loaded in the eager phase. If possible, try to preload product images. And also, if you have like large GraphQL queries, for example, for a search, to reduce waiting time, you can also send those early. In the lazy phase, typically for commerce, what you can do is add like everything that's additionally happening on catalog pages, for example, breadcrumbs, which in the case of commerce are usually also dynamically fetched from commerce APIs. And in the delayed phase, we have like the commerce-specific marketing technology, like the features you use for the intelligent commerce features, like collecting storefront events. However, there's a bit more what we can do. So commerce blocks generally are or can be very complex. So not everything a single block is actually rendering might be required for the LCP. Let me give you an example for this. So on this slide, you see a number of screenshots that demonstrate the progressive loading of a product list page. The important part here is to make sure that you actually understand when you want to optimize it, what is the LCP for this block. In this case, so the browser considers one of the first 2 product images the LCP, but this is just because this is like the mobile view. If you have like different screen sizes, that might be a bit different. So you need to be careful what you optimize for. You can see, so this block is loaded in the eager phase, but despite it being loaded in the eager phase, you see the LCP happens quite early with the 2 images, and everything else that's still required for the product list pages can actually be loaded with like a lower priority despite still being loaded in the eager phase. For example, you also see like all the product images that are not the LCP are loaded later. The swatched images the product ratings, and then header and footer. Let's have a bit more details on this. So in this waterfall diagram, you basically see the loading of a product detail page, the network waterfall for this. So at the very top, you can see the code for the actual PDP block that's being loaded. And then once the block is initialized, it actually then takes like the identifier from the URL, prepares the GraphQL request, sends the GraphQL request, and requests then the product data. The key part here is that we first only focus on requesting data that is required for the LCP, meaning most of the product details, pricing, description. Things like variant-specific information, more product images, breadcrumbs, extensions that require additional queries are loaded afterwards or with like a lower priority. Key part here is this allows us to basically render a first version of the product block to make the LCP happen. And this is important not just for the scores, but also for the actual user experience of the shoppers. So they can already see like the details of the product and you can keep them engaged. Also for the same reason, below you see that we try to load the product images as early as possible. Yeah. Everything else, so on the bottom right, so everything else that might be going on your product detail page, like enrichments, product recommendations, or other third-party extensions, then are also loaded after or only on demand. All right. So now you might ask, how do I find out about all of these optimizations for my specific site? One great tool to identify bottlenecks is the performance tab of your web developer tools. So it basically profiles the loading phase of your site and then displays you valuable insights on what's actually happening in the process. At the very top, the more or less white line, what is actually happening is you see a number of screenshots that help visualize what actually happens on the page, like the individual parts of the site, how it's loaded. Below, you see like a network waterfall diagram, which is also actually the source of the diagram from the previous slide. You see below like a timeline of the important metrics, like LCP, FCP, DCL, and more. And at the very bottom, you see like a visualization of the main thread, which helps you to identify like long-running tasks and potentially things that introduce blocking time. Let me add some annotations so you actually can see how the different parts in the diagram correspond to the earlier slides. And what I would recommend is, so there are like typically a number of problems you can look out for. So make sure that all the resources which are required for the LCP are not blocked by like long loading chains or that they take too long to load. For example, you should avoid using like very large images or videos. At the same time, you can also see all the resources that are actually loaded before the LCP but might not be required. So you can also then try to delay those further. When looking at the main thread, make sure that you do not introduce like high load spikes, which might result in blocking time, especially on lower power devices like phones. Try to distribute this a bit more evenly. This is particularly critical for when you load fonts, for example, or like a lot of custom fonts, because then the whole site needs to re-render, and that usually can introduce blocking time if it runs in parallel with something else that's heavy. So I encourage you to get familiar with this tool, use it in your projects. I can guarantee you that it's very much worth it for analyzing the performance of your site. Okay, so earlier I spoke about delaying loading of specific things, but let's get a bit more specific and how you actually do that and a few more recommendations. So if you load any data from like a third party on your site, try to always prefer using the APIs, if they have any, over embedding their scripts, if possible. Most of the time, you do not control what actually the third party is delivering in those scripts, so you basically depend on the performance optimization of the third party. And if you use the APIs, you can build like the implementation or the UI yourself, and then you're in full control. However, you still do not control like the speeds of third-party APIs. So it might make sense to also then, when you load data from third parties via API, do this in a progressive way. First try to add like a placeholder and then just load it, and so you're independent on how quickly or how slowly the response comes in. As an example, we use this pattern when loading product ratings on a product detail page for the customer, which also was delivered from like a third party. Alternatively, so instead of loading scripts delayed, you can also load them once they actually appear in the viewport. You can use intersection observers for this. Again, an example from a customer. So a customer was using like a heavy review widget from a third party on their product detail page. And to not impact the initial page loading performance, we moved this behind the intersection observer, so it gets loaded only when the user actually scrolls down. Another pattern is then to load scripts only when they're actually used. So for example, to handle the logic of a newsletter sign-up form, you only actually need to use that once the user clicks on the button. A great way to implement this is to leverage dynamic imports. So there are two more use cases here. For example, a mini cart, which you usually have on like every commerce site, which is also rendered on every page. So you do not want to load let's say the heavy logic for mini carts every time. So what you can do instead, create like a more lightweight API that, for example, also caches the number of items currently in the backend session. So you do not need to run a query every time, and then only if the shopper actually clicks on the mini cart, which then triggers a get items call, you can then using like a dynamic import load like the script that actually then does the heavy lifting with executing the query and then rendering the products. The same pattern also works for the add to cart functionality. So everything you need, like the heavy logic to add an item to the cart, checking your session and so on, just load it when the user actually clicks on it or is about to click on the add to cart. All right, one more thing, because we mentioned the usage of frameworks recently in Edge Delivery. So if you actually build complex blocks, especially for commerce use cases, you might get easily overwhelmed by their complexity. So it might be useful to actually use a JavaScript framework, which specifically makes like state management or interactivity easier. In particular, also if you consider like all the progressive loading techniques I showed you just now. A library that worked very well for us in a customer project is Preact. It's very similar to the popular React library, but at the same time, it has like a much smaller footprint. Important is so we do not sacrifice performance. What you see actually here on the slide is like a buildless version of Preact that runs in your browser. So exactly like you see it on the slide. There's no build step required, no Webpack, no Babel, nothing. Just runs like this in the browser. As templating language, we use HDM instead of JSX. Syntax is very similar, but it uses also the native JavaScript tag template notation, so you also need no build step for this. And this also helps you to write like readable markup. And as you can see at the top right, if you want to use that, you add around 5 kilobytes for Preact, 1 kilobyte for HDM. If you're a fan of the hook notation, that's another optional 2 kilobytes. And yeah, so they can use this for building more complex blocks. But I would really just like highlight, only really use it when you need it. So if you build blocks that just decorate content, you will most likely not need it. All right, and since the question comes up frequently in discussions with fellow developers and customers, also a quick word on server-side rendering. So today in our recommended setup for commerce sites, most commerce data is loaded and rendered client-side only. And we can do this because we have APIs that are very fast, the ones I introduced in the beginning. And this also makes the whole implementation simple. So we do not run into any issues with like stale data, since we always load the latest data directly from the source. There can be a few issues though, where you might need server-side rendering. So I already mentioned the case where you do not have fast APIs available. But yeah, if you have like a very complex catalog pages where the page alone, without like adding a block that does the GraphQL call and renders a product page where the budget is already like quite used, you might need to make some cuts somewhere, and moving some of the logic to the server side might be an option. Also, if you want to use calling protected APIs, you cannot do that directly in the browser. You might need some server-side rendering step. What we recommend if you do that, try use an edge worker on your CDN. Be aware of the complexities you add with that, because you need to then handle cache invalidation, have additional complexity and cost. All right. Since time is nearly up, let's do a little recap. So the architectures and strategies to optimize performance, which I showed you today, will help you build successful and super fast Storefront experiences, which edge delivery services. But even if you do not plan to do that, so the learnings I showed you are applicable to traditional AEM websites, or in general, any website where performance is important. Also, please expect some more material and guidance on content and commerce projects on edge delivery services very soon. You'll also find some more references then in the PDF version of my talk. If you want to join the conversation on edge delivery services, again, the reference to our AEM Discord community. Thank you.
Yeah, let's start here. So Roy is curious. Does this mean that the existing commerce integration framework, CIF, is already deprecated?
Actually not. Since we have like a very tight a very nice collaboration with the Adobe Commerce team currently, and one of the features or things we're working on is actually introducing these new services and also let's say the components that come with those services into stores that are driven by AEM. So for example, you will be able to leverage the live search features on AEM stores built with CIF very soon.
Then Vugar would like to know, is Commerce using Adobe I/O runtime to fetch product information?
No, as far as I know, so the Adobe Commerce services have like their own implementation. They're not based on Adobe I/O.
And then his follow-up question is, if not, what happened to Adobe Runtime?
You can still use Adobe Runtime. For example, maybe just one example, what we did, for example, in a Franklin project. So the case I mentioned where you have like protected APIs, that might be a very good use case, for example, to use Adobe I/O Runtime, introduce like a captcha, some kind of rate limiting in front of that API, and you can use Adobe I/O Runtime for that.
Then there's also the question if there's like a rough ETA for the availability of the commerce components.
That's like a very difficult question. It depends on the complexity of your store. So currently we're working with a few customers in VIP projects to basically build out these components. And of course we start with like the simple ones that do not have like a lot of extensions. They will be available very soon. You can some of the components for live search are already available today. But yeah, depending on how complex your use cases are, the longer it will take until all of those will be supported by the components.
And then Alex would like to have that you can showcase a simply Hello World example for showing page server time, but I guess that's more something for the playground session.
Yeah, I have, if you check the references of the talk, there's the website of our first live customer. Unfortunately, because of I cannot show you that today. Also make sure to disconnect from the Wi-Fi because they have like a very heavy bot blocking mechanism in there. So if you all access that site with the same IP, you might get blocked very easily. But yeah, in the references, there's a live site you can have a look at.
Then final question for now. Talking about accessibility, would screen readers even appreciate this?
Yes. I mean, of course, the whole accessibility part is still something you need to implement. So when we talk about the drop-in components that Adobe Commerce provides, we also want to achieve like a 100 score in accessibility. And the accessibility process, I mean, they also understand JavaScript, so they don't have a huge issue with reading those sites.
Yeah, and for all other questions, playground session this evening, Edge Delivery Service table, and your questions hopefully will be answered. Thank you, Mark.
Thank you.